give an update on the changes. Next slide, please. So just to refresh everybody's memory, I'm going to start with the simple part, which is the data path. So basically, there is no data path changes in this proposal. The main proposal is, again, to try to signal PIM access networks through a beer core. So what that means is that when the PIM signaling on the PIM domain arrives at a boundary beer router, we need to terminate that PIM signaling and somehow signal the need for the join or the prune throughout the beer domain. To signal that, in this picture on P2 and P4 as an example, they terminate the PIM signaling, and then they need to signal the PIM join to P1 and P3. To do that, we look at the source, in this case PE1, and we try to resolve the source via an egress beer boundary router. And this is where most of the comments were in. Basically, the questions were, well, the comments were, how do we find out the egress beer boundary router? Next one, please. So I already explained this. Yeah, please, thank you. So the comments that they came in, we came with 4 ways of finding the egress beer boundary router. Number 1 is a static route, which is pretty obvious. So basically, you create a static route with the source, and you say next hop is the egress beer boundary router. So obviously, to resolve the egress beer boundary router, it's a recursive lookup, and eventually you will get another beer router within the beer domain. And then you can actually put the right bets on the bet index and forward that signaling packet to the egress beer boundary router, which eventually removes the beer header and forwards the PIM packet all the way to the source. The second pretty obvious one is BGP. What that means is that between the egress beer boundary router and the ingress beer boundary router, the edge routers, you create a BGP session and you advertise their beer prefix ID through that BGP session. Again, it becomes a recursive lookup, and you can find your path throughout the beer domain via that recursive lookup. The third is some operators, they have an ASBR or an ABR, and these routers, they summarize the route. And we can use the field in the summarization route, which is the source IP, to actually figure out where the egress beer boundary router is. So in short, what we are saying here is that the ABR is the egress beer boundary router that did the summarization of the route. And the last but not least is the CSPF. Basically, the idea here is when we advertise the beer extensions via IGP, every router knows who are the boundary router, and we can do some kind of constraint shortest path lookup saying that I want to go to this egress beer boundary router, and hopefully the routing returns the right next hop for that. Next slide, please. So since it has become adopted by the working group, we consider this solution complete. I believe there has been some implementation of the solution already. And definitely we are seeking more comments. Any comments are more than welcome. But our intent is to go last call on the next IETF. So hopefully we can close.
So what's the intent of skipping? I mean, if you consider it complete now, right? What's the intent of waiting until after the next IETF?
Just in case if there are any extra comments that needs to come.
Just holding out for comments.
Exactly.
All right.
Isn't that what last call is?
Yeah, exactly.
Effectively is.
You'll get a lot more comments in last call.
We can go last call.
Go fast.
Perfect. Thank you.
Excellent. Questions?
No.
All right, we go.
Stig Vanas, I think this is a great solution. I just have like one very minor, maybe silly comment. But to me, like ingress and egress is used like opposite of what I would expect in this document. So I always find it hard to read. I kind of wonder, is it just me, or what do people think in general? What is the best way to use those terms?
Yeah, Greg, I kind of went through the same thing. I understand the intent, right? There's data egress and there's control egress. I don't have a suggestion on how to clean it up, but it was kind of hard for a while. Maybe I look at the acronym is different. And once I look at the acronym, I know I'm talking message versus data. It might work. Just read it a few more times.
I just kind of so used to multicast for the signaling is the opposite of the data path. Whatever.
At least we got rid of RPF.
Yeah, thank you. Again, as you guys said, it's signaling terms and data.
All right. Who's read the draft in its current state? Who believes it's ready for last call now? All right. Hands up. Who those who read it thinks it's not ready for last call? All right, solid. We'll take it to the list. Thank you.
Thank you.
There you go. Good work, man. We had to jump right up here. Appreciate it.
No, the other one.
The other one's first, not on the agenda.
The IPA,
Yeah, the agenda has this one first, but you want to go the other way around?
yeah, sure.
All right. Cindy should have commented to the agenda at the list when I asked for it. So I'm just pointing it out.
All right. So a few weeks ago, there was a big discussion about the two fields that in the OSPF and ISS extensions.
Actually, can I interrupt you just a second here? My mistake. We got blues going out. I needed a note taker. I ran into this thing right away in a hurry, and we don't have someone taking minutes. So let's just pause till we get minutes.
Note taking and Jabber.
I'm on Jabber anyway.
Okay, so we have Jabber
Notes important.
minutes. We were clearing names up there. You got them now? Thank you. Appreciate it.
To fame,
So-
that stuff.
That's perfect. So you can fill in the minutes from the previous presentation that you gave. All right, ideal. All right, Jeffrey, go ahead. Thanks.
So that big discussion settled, but with one deferred item. It's basically the general rules how these two fields should work together. So this draft is about that. So problem statements, how are the beer forwarding paths determined, calculated, and how those two fields work together. Next, do you have?
I know. Just
Okay, all right.
Just say ding.
Okay. I'll skip this slide because we have quite an agenda. Yeah. So to calculate the forwarding paths, let me explain some terms first. So calculation is applied to topology, maybe subject to some constraints. Here, the topology is basically a graph of nodes and links, and each link has a set of characteristics, including metric or color or whatever. And algorithm examples are shortest path first, or could be spanning tree in the future. The constraints are like use T metric, whatever metric, or it could be excluding the red links, things like that. Those are just examples. Next slide. And then when it comes to bar and IPA field, the bar basically beer algorithm, IPA is IGP algorithm. So both can be interpreted as two components. One is the algorithm, the other one is constraint. So we have this BA, beer specific algorithm, and BC, beer specific constraints. And correspondingly, we have routing algorithm and routing constraints. So the bar is basically the BA plus BC. IPA is basically RA plus RC. Next slide. So in general, the rules are like this. We start with the topology, which could be the default topology or a multi-topology, particular multi-topology. We apply the beer-specific constraints that gives you the BC parentheses X. And then you apply the routing constraints. You get next one, the RC, BC, X. And then you've determined the algorithm to use. Currently, for simplicity, if the BA is not now, we just use the beer algorithm. If otherwise, we just use the routing algorithm. In the future, this could be enhanced, but for now, let's just go with simple. Let's just state that if you if you don't have, you just don't mix them together. But in the future, they could be stacked together. And then you apply the algorithm to that topology. Next slide. So a few notes. For bar 0, that means that both the Beer-specific algorithm or constraints are null. In that case, the IPA alone dictates the calculation or dictates the routing underlay for the Beer forwarding. This second bullet was added recently. It was not in the spec, in the draft. It was after some discussions among the co-authors recently, yesterday. We believe that it's good that that we can allow the overriding in the future by individual bar IPA values. But in general, the rules are what we just talked about in the earlier slide. But for flexibility, when we define individual bar IPA values in the future, they could be overridden. And another important point is that if you're doing a calculation for a particular subdomain, and your configured bar IPA value is different from another router that signaling for the same subdomain, then the other router will be treated as incapable of supporting beer. How that is handled, there are different ways. Actually, I'm going to talk about in the next presentation. Next slide. So we're seeking comments, and we believe that we have got good support on this general rules, and I think it's ready for working group adoption. But comments are always welcome.
Questions, comments? Go ahead.
I avoid walking through. So just kind of to
Name.
We have people on Metro.
Yeah, we
please
need the mic.
Use the mic.
We
We
need
need
the
the
mic.
mic. This is
Use the
important
mic.
discussion.
You can always take it off.
Just-
Keep going.
you guys put on the mic and
You can grab the mic there before then.
Sorry, thanks.
Mobility, it's kind of crowded.
Yeah.
Yeah, thanks.
Hi, Andrew Dolgan, Nokia. So just for those maybe who did not follow everything and the slides may be a little bit confusing. The whole intent of bar and IPA is, if you have a bar 0, it's simple, yeah. Like whatever is in an IPA field dictates your algorithms, and IGP dictates IGP. In case the bar is not 0, then we really will leave the definition. So we have an example here. What can it be? But we really leave the definition to that non-zero value. What would it actually mean, and what type of values in the IPA fields are allowed or not allowed? Because otherwise we're gonna go into hypothetical discussion, which we try to avoid. There is some framework, but it allows independent bar. It allows IGP running and leaves the place for both of those two to interact in a kind of simplified.
Okay. While I'm here, hi Cisco, and also maybe one clarification here still. So if bar is 0, so we look at the IPA only. But just to make clear, when that's the case, we don't expect a specific calculation to happen by Beer by creating topology, right? We depend on a IGP topology to be there.
Yeah.
And that's what we want to point at. So we're not proposing any specific calculations just for Beer.
Correct. Then there's also implementation dependence. It's protocol wise. Yeah.
So who's read the draft? All right. Who thinks this is an item we should adopt for work? All right. Pretty solid. Note that. We'll take it to the list. Excellent. Thanks, Jeffrey. Hang on. And now, right.
So handle beer incapable routers. Next slide. So we talked about that in the previous presentation that BFR signaling mismatched bar IPA values will be treated as beer incapable. And then also in a beer deployment, you could have routers that cannot support beer at all. How do you handle those routers? This draft, beer algorithm draft has one proposal, which is method number 4 in this slide deck. That draft also covers other topics, but in this presentation, I'm just only going to focus on this particular problem. Next slide. So method number 1 is what's already talked about in the beer architecture spec. It's basically that at the end of the SPF calculation, you examine the immediate children of the calculating BFR. If a child does not support beer, then you replace that child with its own children on the SPF tree. And that child's children may not support beer as well. So you just repeat this process until all the calculating BFRs and immediate children are beer capable. And now at that time, you could have some immediate children on the SPF tree that is not directly connected. In that case, you just tunnel beer packet to them. Straightforward. Method number 2, I'm here is just giving an example using flexible algorithm. It could be that you mark all links to that beer incapable router with certain color, say brown, and then you define a flex algorithm to exclude those brown links. Also, if you have a base flex algo, let's say you exclude red links, then you have to copy those rules over to this new flex algo. So that means that you have to have an extra flex algorithm for each base flex algo, just for the beer purpose. And if a router is upgraded to support beer, then you have to remove those brown color on those links. Just 1 second. So a variation of this is just use multi-topology if you're not using flex algo already. Go ahead.
Hey, it's Peter from Cisco. Just a comment that you don't necessarily need to do it on a per link basis. You can do it on a per node basis, which is much easier to do using the flex algo.
Per node? Oh, I think, yeah, I think I covered that on the next slide.
Let's try to spin it.
Yeah, okay. Next slide is just that you define a flex algo saying that skip beer incapable routers, and then very similar. Next slide. So finally, we come to beer method number 4. We basically define bar value 1 here is beer specific algorithm here. Well, the algorithm is the SPF. The constraints here is that you skip beer incapable routers. With that, you do not need to define any new topology or flex algo. But if you have flex algo or topology, it works together very nicely. Next slide. I have some comparisons here. Against number 2 and 3, you have a less signaling overhead, provision and signaling overhead. And in particular, in number 3, you are basically defining something specific to beer in the flex algo. Then between number 4 and number 1, implementation-wise, number 4 is easier. Basically, when you put a node into the candidate list, you just skip it if you don't support the beer, and the rest is just the same. Now, one important property here is that with method number 1, you have congruent forwarding between beer and unicast. With number 4, essentially you're making them incongruent, but that is something that's maybe desired in some situations, or maybe not desired in some other situations. Next slide. So we believe that doing it this way has a practical use and advantages depending on the scenario. So we want to go ahead with this bar 1 definition, which is SPF with beer incapable router skip. So we are seeking comments, and we will probably just refocus that existing draft to on this particular topic, and after that we will seek a working group adoption.
Tony P. So, I mean, as a practical observation as well, I mean, we don't have to define anything at all, in a sense, right? We can support non-congruent topologies by using multi-topology, right? And people setting up tunnels and putting them into multi-topology. The beer, as it stands today, doesn't need really any extensions to work, but all of these things have different advantages, disadvantages, and preconditions what you have to deploy to make it work.
Julius Krobachek, just a quick comment. In everything you're presenting, you are assuming that the IGP is link state, which is fine because, I mean, if you read the architecture document in Beer, you can feel that the authors are thinking in terms of link state. But I think that deserves to be mentioned. Beer in itself is not restricted to link state, and here you're assuming link state.
You're correct.
So stop dragging your feet and solve the problem for us in Babel. Come on.
Hi, Cisco. So my first general comment would be that, let's say, building a topology that only includes your beer routers is very topology specific, right? Because if your primary path is not beer capable, you expect then to be another path to be beer capable. Right, so, but that's not good enough, because if you want redundancy, you need to have another path yet that has a beer router in order to, to be able to converge. So I'm not so convinced that this is actually a good way to deal with, non-capable beer routers. So I would think that, what's in the architecture draft to skip through a router, tunnel through it, is a much simpler, and much more realistic way to solve that problem. But I know, okay, sure, there are cases where this can be useful. My concern with option 4 is that you probably, let's say, if you want to make that work, you probably end up doing something like FlexAlgo already does. So you might actually be duplicating efforts there. So,
I don't see why we are creating something duplicate compared to FlexAlgo. In fact, with this method, when it comes to provisioning or signaling, that saves you trouble from having to create a duplicate FlexAlgo or topology except with the beer removed from the incapable router from that topology. So that part I don't understand. But as far as requiring your first comment, I think that even for the method number 1, you also need to have your beer capable routers.
Yeah. Okay, guys, so we really tight on time. Take it to the list. And I mean, don't forget that, yes, things work. Every solution is the simplest solution if it meets the assumptions to make it work, right? But take it to the list, discuss the stuff. Let's ref this thing. Let's keep the stuff flexible, all right? But we have to move on, right?
Yeah. So just skipping to the end of the comments, this is all, in my opinion, about what's operationally, for example, the most easy way to get this thing running in the presence of non-beer capable routers. So
yeah,
maybe,
but
wait,
there will
can
be
I
a lot
just
of people
finish
with
the
different
sentence?
opinions. We
Yeah.
have to move on.
So maybe also discuss this in MBOND, because it's an operational issue. Really, what would be most simple?
Okay.
Because it's not sure if we have all those folks here.
Sure.
Okay.
Who's read the draft? Who thinks this is a working group item we should adopt? We got. Okay, we'll take that to the list then too. Thanks, Jeffrey. And we are. Stig, thanks, man. Jumping.
Yeah, hi. I'm Stig Vanas. I'm going to talk about MTU discovery. So I think we need to talk more about MTU discovery in this group. And this is like one proposal. We have a smaller proposal, or actually working with document already about MTU discovery. But I think it's worth discussing more, what approaches we should follow and what the benefits are and so on, the different approaches. So I'm sure you agree we need MTU discovery. Basically, when an IP packet enters a beer domain, you need to be able to send packet to big or something for IP MTU discovery to work. Also, when you do overlays like PIM or IGMP and so on, we need to find the MTU so that we can send maximum size joint prune packets or IGMP version 3 reports. We want to pack as many S, G's, or whatever inside those reports as we can. So what I'm proposing here is a way of doing a subdomain MTU. So basically, instead of the usual path MTU, it's finding an MTU that covers the whole beer domain. And one advantage of that is that it doesn't depend on the receiver set. Usually with path MTU discovery, whenever a new receiver joins a multicast flow, you might change what the actual MTU is for that tree or that flow. So that gets complicated. Also, if there's some kind of rerouting, and then the MTU might change at any time if you do path MTU discovery. By doing a subdomain MTU, we can make it more static in a way. Also have some text in the draft about how we might, if a link goes down, you may not update the MTU right away if it goes below. Becomes higher. Rather just be kind of slow to update the MTU, just try to make the MTU kind of more stable. The working group draft we have already talks about using probing for MTU discovery, and that's useful, but I'm a bit concerned that it takes a while from some network event happens until we can probe and find a new MTU. Also, it will be per flow while this is per subdomain.
AC Lind of Cisco Systems. I just looked at this really quick. I read the draft really quickly, but if the IGP domain and the beer domain are the same, this MTU, I don't think many devices support different multicast and unicast MTUs. It might be useful to other applications to make it generalized rather than putting it within the advertisement specific to beer.
I know, I was thinking a bit about that, and ISIS also has some way of doing this using Trill. I kind of would like to have something that is beer specific though, because beer adds some overhead and it depends on the encapsulation, what the MTU is and stuff.
Okay. This is Greg, Cisco, but it's still MTU and it's still one operational domain. So I guess what I would ask is that from in the text, like you look in the slide, it says it is useful for beer ingress router to know. Why? It seems to me more of a configuration like evaluation. Because if it's my overlay domain, I'm setting 9K and I'm done link to link. I may have missed one, and I'd like to have a tool to find that one. But I'm not crossing domains where some other operator has something not understanding that I'm encapsulating and forwarding.
But you need to know what's the MTU of all your links in your beer domain, and then I guess manually configure each of the routers with whatever that MTU is.
I don't think operationally that's really how you build a network. Really, it's like if I have an operator network and I have, I'm doing overlay, I've got modern Ethernet interfaces and I'm set 9K across the board. I may have messed up and not done one, but I'm not crossing my domain. Like normal path MTU for IP is end to end, and I'm out of my domain into someone else's, and I don't know what they've done, and I need to discover that to ensure that I have to shrink my packet size so I can get through there, or I'm fragmenting. But this is one operational domain, and so the consideration is different than path MTU for end-to-end internet.
It partly is, but at least one thing is a packet might be coming from anywhere, entering your domain and your beer domain, and you have to be able to send at least some kind of report back. So you need to know what is the MTU in the beer domain.
So the intent, then just when is it useful to know for what purpose, to do what? I would just ask that if the question gets answered.
Yeah, that's my first bullet here, basically.
Very quick question. So before beer, was this a problem?
It is a problem. So what we're doing today with multicast, for IPv6 multicast, you're supposed to do path MTU discovery and send packet to big and so on. And basically what routers have to do is they need to look at their what happens today is you basically get the packet to big in response to a multicast packet. So it would get forwarded down the multicast tree, and at some point, some router might send a message back saying this is too big.
Yeah.
And you need to keep updating what is your MTU for the tree today.
Okay, I was never Charles Eckert. I was never, persuaded that the active probing would scale. I mean, beer domains may be smaller for on a individual BIFT basis, so it might be more useful here. But I think the most important stuff was to put in the advanced IPv6 socket API. This stuff default is 1280, and hopefully it's good enough for you when you do multicast. So get away with the problem.
Yeah. The other new issue we have here, by the way, is for the overlays. It's very useful for the overlays to know the maximum packet size.
One more question.
Okay.
So Human Nokia, just to ensure I think you answered this, you're trying to discover the beer domain MTUs, right? You're not going to be looking at the host or anything like that.
Right.
It's just trying to figure out what is the extra header of the beer, right?
Yeah.
Isn't that a static though?
No, basically you would look at, say, the layer 3 MTU or IP MTU perhaps of all your links in the beer domain. And you would have to, for each links or interfaces, you'll have to subtract the beer header to find out the beer MTU. But yeah, if you could find the layer 3 MTU of your beer domain, and you assume that the encapsulation size is fixed, or the header size, then you could calculate it.
That's exactly. I thought beer header is completely static, right? So as if you use the IGP MTU and subtract that, then wouldn't that give you the answer?
It depends a little bit whether it might be fixed in a subdomain, but it depends a little bit whether you're doing, say, beer with an MPLS label, if you're doing beer over Ethernet or beer over IPv6 or something. Perhaps.
Okay. All right. Last slide. We're hustle here.
Yeah. Okay. So I wanted mainly to have a discussion whether this is useful and stuff, and please comment on the list. But this last slide just talks about how you actually do this. So the idea is a router looks at all its local interfaces with beer neighbors in a subdomain and finds out basically what is the smallest MTU of all my local interfaces. So you basically announce in OSPF or ISIS what is the largest packet I can forward out of any of my local interfaces. And then, a router can look at what everyone announces. They announce a beer prefix tagged with this MTU, so you can say, okay, this is the minimum of what everyone announces, so that's our subdomain MTU. Yeah, okay, that's it.
All right. Any other questions? Who read the draft? Is the intent of adoption?
It probably needs more discussion.
Okay.
I guess I'm curious so many people, think this is useful.
Well, the discussion usually takes place in a better form if it's a part of the working group work. So who thinks this is something we should adopt as working group item? You see some hands in there too. It's worth taking the list at least. All right. And maybe the drafts merge in some way. We talked about overall solutions. All right, let's take it to the list. Thanks, Stig. Next.
Can you start with the other one?
You guys never pay attention. Arc, all right.
Okay, this is just a single one-slide update on the BRT forwarding architecture through adoption. So there was the ask from Aliyah to basically better describe the forwarding plane differences between BRTE and beer. And so that's what I added. And actually now with the other work we've done, there's one, bit of clarification needed. So the really main difference is that in beer, you're looking at all the bits because they're all BFERs that you may want to forward to. While in BRTE, every adjacency is only interesting to you if it's a direct adjacency that you have. So you're basically applying on ingress with a packet some end of only those bits that are really your known local adjacencies, and you ignore all the others. So that's really the main difference. Then as far as the representation of how we have it in the document, so normally the way we've been thinking about BRTE, the forwarding bit mask, the stuff that you end when you send out a packet, that actually would be the same for all the copies in normal BRTE. So now when we sat down this week and we're thinking about the other stuff that you'll see about the traffic engineering and perf, we figure out that we'll also have the case when we want to have better OEM where the forwarding mask would also be individually calculated on a per outgoing interface. And I think that will become clear from another presentation. So that's pretty much the only thing, and I'll try to update the text to be more clearer and maybe try to see how I also get the terminology better aligned with the original B forwarding in the pseudocode that I have in the draft. That's it. Next one. Right, so with this being standards track and trying to let the most expert group do the things that they're good for, the IETF working group for traffic engineering architecture overall is called T, so I brought beer to T. Next slide. Okay, so there are a bunch of, this is all just not for beer people, so skip over all of that. That's,
Skip.
Just skip.
Skip. Just say ding, ding, because all of that is a little vague.
Yeah. Okay. Stop there. So yeah. Right. So the new thing, and that's going to be in the other presentation that we're bringing in, is basically really the dual live stuff. So that's better on the other presentation. Next slide. Right. So then basically, I think what we haven't really described that well in the beer forwarding architecture, which is more interesting for the controller, is the fact that how do you think about on the sender side application, how to set the bits for a particular set of receivers. Normally in beer, it's just 1 bit per receiver. And the equivalent in beer TE would be somebody calculates you for every receiver a bit string, and you just OR them together for the list of receivers you want to have. Right, because every bit string would indicate a path, and if you just have multiple receiver and you OR the path to them, well, you get basically your distribution in the network across your traffic engineered path. And so that's basically kind of the starting point of the model that ultimately would become, parts of an API between a BFIR asking a controller, please give me for a set of receivers or for the superset of all receivers the traffic engineered path. The way I can see it is that you will have policies like saying, so the VPN foobar should basically get a path set XYZ, ask the controller for, paths for XYZ. So that's kind of the operational model to work out between a BFIR and a PC controller. And of course, this thing kind of pre-calculating everything doesn't work for Steiner trees, so there obviously are different forms. Next slide. So here is basically the overview, kind of expanded from what's in the forwarding architecture with the new aspects. So we had that BFIR, BFER, and then going to a controller host. And in the original forwarding plane architecture, we didn't include considerations for the IGP. And in this TS architecture, we expanded that with proposals on how to leverage the IGP in similar shapes and forms, like it would be done in RSVP-TE or even in segment routing, insofar as that the IGP is optional, but it could basically, if used, provide distribution of the BRTE topology so that the BFIR could calculate path itself, and or that all the nodes in the network could basically figure out inconsistencies in bit configuration and even some auto configuration of the more complex adjacencies without the help of a controller. The controller will always be required for the initial provisioning, but then, during the build of traffic, we have the alternatives to use the controller explicitly or leverage the IGP. So kind of that's the highlight. Next slide. Right, so this is the data model. Just wanted to compare it quickly to beer. Right, in beer we have in the IGP the announcement from every node, what basically his own BFER ID is, the MPLS label range, and then more stuff like all the IGP stuff we said, flooded via the IGP, gets into the routing table in a node. The routing table also has the BFR IP identifier, and then the next hop. So that's basically taking the calculation, going down to the forwarding table for which we calculate the FBNs. Next slide. So this is basically the equivalent in BRTE, and the big difference, of course, is we're not doing shortest path calculations, so the whole kind of routing table level goes away, but instead what we have is per node exactly the local adjacencies, all the bits that are directly adjacent to a node, given bits for every node. That stuff would come down from the controller being configured on every individual node, and then basically we could flood this in the IGP, and then basically the BFIR could calculate paths through it. We can also flood it through the topology, and then basically from your own configuration and the known topology, We can do consistency checks. Oh, wait a second, this bit is totally messed up, wrong configured. Maybe we take it down and basically don't allow forwarding on it and alert the operator. And then also the auto configuration. But the forwarding table is really the same as the topology table, except with all the metadata to describe things being stripped out of it, and maybe some auto-discovered adjacency bits. Next slide. Right, so when we think about this really in the form that also the operational models in Yang and Tor are evolving, right? We have this configured BRTE topology, and that's really very interesting to look into, configuration inconsistencies and to do auto configuration. But obviously, when we want to calculate path, we really want to know which bits are operational, which bits are really the router likes to do forwarding on and hasn't taken down. So that's why the proposal for the IGP stuff would really be that we consider really two instances, the configured and the operational one, and clearly distinguish on them and have the different operations run on them. And depending on which operations we want to do distribute in the network, we would need to distribute both instances of them. And maybe there is a way to make it into one, compress it. So, but that would be future work for the IGP encoding. Next slide. So this is basically then the kind of not yet complete, correct, abstract form, right? So these are the different adjacencies that we had in the forwarding architecture and trying to really get to the data model in Yang of these. Okay, next slide. Yeah, so this is all, I think, it's when we're running out of time, let's take it to the next one. So this maybe one is the interesting auto configuration, right? When we don't want to do replication on every node in the network and we have the routed adjacencies, one of the typical use cases would be that you want to be able to just send from this node to either of these two nodes as a traffic engineering thing. So you have all these adjacencies and we can automatically build them. This guy is only announcing the adjacencies. These people set in the bits, and that would be auto configuration through the IGP. Right, so if we're running out of time, I think that was kind of the highlight. There are, more details. It's a start of larger work. And yeah, I think we can, skip the other pieces.
We're down the last one here anyway. Oh, one more note.
Let's end with, just go on.
Next steps.
Next steps, right. So discuss, determine the order of the next steps, right? For me, kind of building for the topology, the Yang model, kind of configuring the beer domain, that seems obviously like the first step, then PCEP protocol to control from a controller, and then slowly trying to figure out where to go with the IGP. And then, of course, improve the framework according to guidelines from TEAS. And then basically all the cool things about Pref and OEM that we'll talk about in the next presentation.
So very short comment, the traffic engineering topology, Jeff Tensura, traffic engineering topology, tunnel topology, it's all in TS, make sure it aligns with it.
Yeah, that's exactly, yeah. Mm-hmm.
What was this extended work? You said adopt a TE was an intent. You said adopt a beer TE. So take guidance from TEAS is where you're going next.
Oh, yeah, no. I mean, I think this draft specifically would go into TEAS. Sorry, that's a typo.
Good. Thank you. All right. Next is TEAS, ARC, HTTP using beer.
Hello, everybody. So this is on behalf of my co-authors. I'm Debashish, and this is just a quick recap of the one of the previous draft, which basically describes the use case of multicast HTTP using beer. Next slide, please. So in terms of like a quick recap, this is a realization of the use cases, and in that a few requirements were listed, as well as certain operational details were described in terms of how to realize the use case over a beer. So if you go to the next slide, please. So now in terms of the updates to this one, like in terms of this applicability of this use case, in the earlier draft, we mentioned about video delivery or video multicast. We basically describe it can be applied to other use cases also. And there was also a question about if there is, without beer, if it is it possible to realize. So we basically bring about other solutions where this use case can be realized without beer, and also some clarification with respect to existing technologies such as edge multicast flow compute nodes. So if you go to the next slide. So in terms of applicability of the use case, so this HTTP multicast can be also seen to be useful or related to other use cases such as virtual reality and V2X use cases. In case of virtual reality, there are situations where several users join a VR session at the same time and is centered around a joint event. And we see multiple requests are sent for the same content at any point of time. Similarly, in the V2X use cases, as we see in a particular location or geographical area, as more than one vehicles enter, they may send for geolocation related content to the same content server at the same instant of time. And also, we have been working on a point Horizon 2020 project where HTTP level multicast use case has been executed on SDN based and ICN based underlay network. Next slide, please. So in terms of state of the art, like what exactly is this use case and how it can be realized. So just to give a brief background, HTTP request and response are routed based on the URI in this use case, and URI is used to identify source and destination. And these requests are routed using path-based forwarding mechanism. And this request is, as of today, like if it's an HTTP-based request, the path-based forwarding can be done using a service router. The next slide, please. So, this use case can be realized using existing transport technologies such as SDN, where we can use the SDN feature of path-based forwarding through this wildcard matching fields. What happens there is the Ethernet frame format layer 2 can represent the topological links of a specific forwarding path in the transport network. And this in this approach or the implementation, the IPv6 source and destination field is being used for storing this bit array information. Next slide, please. So with respect to existing solutions, it is again, just to clarify, this is completely an overlay solution over beer. And this is more like it's a multicast where it is an ad hoc multicast. That is, the multicast relationships are built at the level of each HTTP response and therefore can vary from request response transactions. Whereas this edge multicast flow aggregators assume a stable multicast relation, and that can be mapped into IP multicast. Next slide, please. So I think so in terms of next step, is this makes sense for additional investigation on this applicability statement document and how beer can be applied or how this use case can be applied over or used over beer. So does that make sense to look into that further? So with that, I end my presentation.
Julius Krobacek, just a quick question. What's the transport layer protocol?
That is can be we're saying it's over beer. And then it can be anything.
And what do you envision?
We as we said, we are basically talking about like Ethernet or SDN based.
No, I'm speaking about the transport layer. HTTP requires reliable transport. So what are you doing to provide that?
We can, as I said, we can use it over normal TCP or IP. So we in that case, we don't really care about that. It can be.
Well, it would most likely be something like UDP so that you don't have problems with all these TCP sequence numbers, right?
Yeah, but so as we said, we are agnostic to that, yeah.
Right, but I mean, if you have to deal with TCP sequence number, you'll have to do a lot more work to figure out how to make that work. While with UDP, you just send the. So I think this is very cool. I'm not sure if kind of the coolness really comes through right now very well, because the whole point of sending the copy of the right bit rate to a subset of receivers that can support exactly this bit rate at the point in time is exactly what you couldn't do with native multicast. So I think maybe that really should be on top. And then really the question is, can we really do this right now with our charger? Because this would be a video server sending the stuff and a video receiver, and we're kind of somewhat tied to these crazy service provider edge routers doing beer. So this is, I think, exactly the charter question with something like this.
So as a chair, this is a use case. And if the use case is interesting, I don't think it's outside charter necessarily. If there's elements of it that require collaboration with other work, I would definitely reach out. But it's ultimately 80.
Well, I think there are dependencies like APIs for beer for application and these things to make it
right. Those are layers beyond just finding the solution.
Yeah.
Rachel Huang. This use case, makes sense to me, but I'm not sure it should be in beer. I'm not sure because it looks like to me it should be related, video delivery or something decoupled from the network architecture or something, network layer protocols. So it maybe can be solved by some, maybe application layer, just signaling or something like that. But I'm not sure beer have to solve this problem. So I don't understand. So what you want to achieve in beer? So.
We want to use the beer, the path-based forwarding that. So we want to use, as I mentioned, it's a complete overlay on beer and use the capability of beer.
Yeah, but still, it's unclear how to achieve that. It looks like not a problem, to solve this.
So maybe just quickly. So one of the key benefits of Cisco. One of the key benefits of beer is that there's no need to build a tree, right? Yeah. So you have immediate access to all your endpoints without having to tell PIM, say, oh, now build me a tree, and this guy needs to send a join. So it's an infinite amount of combinations you have on your fingertips, right? So that's why beer is great for this.
Yeah, just to answer to Rachel's questions, really, if you understand how bit rate adaptive video is, at any point in time, you need to, let's say for a live video that you're sending to all these receivers that have varying bit rates over time. And basically for every, for every picture, you need to send the video in the right bit rate to every receiver. So, every time you send it out, some subsets will have the 4 megabits, some the 2 megabits on each
Torlis,
packet.
we're going to wind off. That's an application layer solution.
No,
We've done that multicast decades ago.
Right, but you can't do it on a per packet basis. You can do it now with beer because you can now set the bit string exactly for this packet. This is the set of receivers that gets the 4 megabit.
Okay. Again, that would be an application solution because you have to turn everything into symbols so they don't have to get the right sequence of packets. It's application layer.
But it's still something you can't do in this way with native multicast. You need to do beer.
You do it at the application.
No, I mean, you still need to build all these different, how will you do that with a tree?
Aaliyah Atlas, sorry about my voice. So the new charter specifically allows for applicability statements where saying this is how you can take beer to use it for different things. And obviously you've presented this work before. And as one of the pieces that was in mind, beer is also recharted to serve essentially as a forum. You could think of it as an education forum to people who are interested from the application area to come in and try and figure out how could they use beer. So the question you have is how much of this particular applicability document is understanding the application and how much is understanding beer. And if it's more understanding beer to apply to the application, makes really great sense here. If it's more the other way around, you'll probably get better review from people who understand the application space.
Right. Tony, so, let's say that's a valid application, an interesting application, and out of that would spin out something like build this funky TCP over UDP that can adapt those rates and change receivers. I think this kind of stuff would get spun out into a different group and go to some HTTP guys who know much better than us, how to hack the URL options, right? But because beer is such a specific technology that allows all these things that weren't possible before, I think this is a good starting point to make sure that they understand what they're getting underneath that they can use, right? Okay.
All right.
Thank you.
Thank you. Sandy.
Good afternoon, everyone. I'm Zheng Zhang from ZTE. You can call me Sandy. This presentation is for Beer prefix redistribution. We have co-author Jeffrey and Ice. And let's see the problem statement. I presented the problem in last meeting, but now we provide a different solution for it. At first, let's see the problem again. This is a typical hybrid network. Different routing protocols run in different regions according to administrator consideration. So you can see the figure above is ECS level 2 domain, and the figure below is OSPF area 1 or area 2 or another. So and the network, the different regions has different network architecture. Not many routers. There are not many routers in some regions, but there is only one hop forwarding in some other regions. Multicast service are provided in the network now by using PIM. But if we want to deploy beer in this network, and from the existed protocol, we can know that we can deploy a beer domain in each IGP region. So we will, in this network, we can build 3 beer domain in it. So the border router, such as R3 and R4, needs to maintain the multicast flow overlay state. And the border router, such as R3 and R4, must convert beer encapsulation. So in this network, there are many beer encapsulation and decapsulation functions run. Next, please. What if we have one beer domain spanning all the regions? If we can do it, then the 3 regions is merged to one beer domain. So there is no overlay state on border routers such as R3 and R4, and no beer decapsulation and encapsulation functions run in beer routers. But the problem is how we advertise the beer information across multiple regions. Let's see a solution. At first,
sorry, yeah, thank you. Interesting draft, but before you go to the next slide, I just wanted to understand, if you go back to the previous slide, please. So just an example here on R1, from data path point of view, from the beer header point of view, are we going to set, if R1 wants to send the packet to RX or RY or RN, on the R1, are you guys setting the bets for RM, RN, RX, and RY?
Yeah,
Okay,
we want
so
to do
it's
this.
just one domain you guys are...
Yeah,
okay,
yeah. We want to retrieve. We want to reach the achievement for it.
Yeah. Thank you.
Let's see the solution. At first, we can reuse the beer sub-TLV with beer prefix redistributed by border routers from one routing region to another. And so the router in all the beer domain can build the beer forwarding plane. So just like OSPF inter-area case. And for beer MPRS encapsulation sub-TLV, it may be included, but it is not needed in the advertised beer sub-TLV because it has local meaning. So if we want to send a beer packet directly to an outer or external BFR, we may use it. It depends on the administrator consideration. Next. Let's see the another part of the solution. Because we know that border router always use summary or default route to advertise the routes to another region. So if the summary or aggregation, you can call it aggregation, and all default routes are used to send to another region. Now, a single summary route, we will not mention too much. A single summary route may cover many BFI IDs. So how can we advertise it? In this draft, we defined a new proxy range sub-TLV to advertise it. So you can see the format is like this. And multiple beer proxy range sub-TLVs may be advertised if the BFI IDs covered by the prefix are located from different ranges. So there is no more one-to-one mapping between individual beer prefixes and the BFI IDs. But for the overlay, we know that the overlay needs to include BFER IDs when signaling to BFIRS. So that's all. Any comments?
Hustle, Peter, run to the mic, run.
Hi, it's Peter from Cisco. So I just have a very practical comment that encoding works for one of 3 protocols. So I would advise to work with the protocol guys to make the correct encoding. And also the draft doesn't say anything about where do we put this. It says it comes with the prefix. There are multiple ways to advertise prefixes. Yeah. So it needs to be some work there to be, clarified. That's all.
Okay. Thank you.
Thank you.
Okay, so I think I commented on the list. It depends what is the intended scope and track of the solution. If this is an informational draft, okay, and somebody implements that, that's cool, right? This kind of start topology will work. If that's supposed to be a generic solution where people just stitch IGP areas together, that makes me very nervous, because then you have to start to run a distance vector protocol to make sure you don't loop. And there is a lot of very ugly cases where you start to redistribute IGP into IGP and you end up with redistribution loops. Plus, normally we don't, during redistribution between protocols, drag large amount of information between protocols, normally architecturally. So if that's supposed to be standards, I think there's tons of work to be done. Okay.
So quick comment here. Cisco. So we're not proposing to build this sort of network, right? If you have this network, you're already doing that, right? You're already redistributing one into the other. So attach some additional information for beer to discover your beer for IDs. I don't think that's
Just the endpoints, it's not reachability.
Yes. Right. So I don't think that makes it any worse.
Yeah, chime in. We need IGP guys here.
It's Peter from Cisco. Just Tony, for you. I guess it's not such a big deal. We did that for the mapping server advertisements, which are kind of, opaque data, and leak them between areas. We make sure they don't loop. We have downbeat. We have other things in our
space.
So
that's what I mean. So then we have to start to talk about proper downbeats and so on.
Yeah,
right?
It's not that complicated. It has
can
been
be
done.
done.
Yeah. All right. Thank you.
I didn't say it's impossible. I just said it's an architecture that needs more, far more specification if you want to really solve it properly in a generic way.
All right. We'll hit Rick.
Okay, this presentation is for beer with Rift. We have Corsair, Jeffrey, and Shaowen. Let's take a glance of Rift protocol. It's a hybrid routing protocol for close and factory networks. And for northbound, we use link state routing. And for southbound, we use distance vector routing. In southbound, default route is used most of the time. And some specific disaggregation routes are used to avoid black holing or provide optimal routing in certain situations. Because there are 2 different features in Rift protocol, so we provide 2 different signaling mechanism for beer advertisement. In northbound, we reuse the beer OSPF or ECs like sub-TLV to advertise the beer information. And for southbound, we use the function we defined in the last draft, the beer prefix redistribute draft, to advertise the beer information. Because MPLS is not always used in data center, So we must consider the non-MPRS encapsulation function. So there is only one difference between non-MPRS and MPRS encapsulation. So what we should do is to distinguish the BIFTID in the beer header. Next. So the beer signaling, like MPRS, label block is used to advertise the beer information. In non-MPRS, we can use two methods for it. One is we can use a unique combination for subdomain, bit string length, and set identifier. And another, we can use a function just like MPRS case. Instead of use the label block, we use BIFTID block. So it's quite simple. Let's summarize the draft. So in Rift northbound, we use beer IGP-like signaling functions. And in Rift southbound, we use the function defined in beer prefix redistribute to advertise the beer information. So, and we use the similar BIFTID signaling for both MPRS and non-MPRS encapsulation. This, because Rift has the Swift schema feature, so we can use we can implement in later. That's all. Any comments?
You're not controversial. Well done.
Thank you.
Torrance, you doing this?
Yep. Yeah, so Pascal unfortunately is chairing another working group right now. So the idea is to offer a BRTE with these extensions that we're describing here as a candidate option for DetNet forwarding plane, unicast and multicast. And so the DetNet pref is the function described down there, and then also some advanced OAM, and that's basically, we think, useful for any high resilience application with BRTE, not only DetNet. So, for example, DetNet may or may not say you must have some certain forms of strong QoS, but we do know that in multicast, high resilience with any type of QoS has been classically deployed. So having with BEER now the opportunity to create a standards version of that, I think would be really highly beneficial. So the pref packet replication and elimination function, to me, it's just a new term for what we've called, in IP multicast, live, dual transmission. A lot of terms have been used around the industry. So the idea is to have packets with flow ID and sequence number sent across two disjoint paths, and then the receivers perform duplicate elimination by the flow ID and the sequence number, right? You just remove the duplicate packets. And actually, in the case of the BRTE solution, it can also be midpoints. I don't have the example here, but I'll have it on Friday in the DetNet session, so where we're going to talk about that in more detail. So this scheme, the live transmission, has been used in IP multicast since about 2010 in video receiver applications. In the finance multicast application, maybe since 1997. So the idea in the application side has been around forever. The feasibility in layer 3 NPU has, I think, been shown in prototypes in maybe around also 2012, 2014. I'm not quite sure anymore. I'm not sure that any L3 equipment with NPU is actually having that in production use, but it is in production use in TSN L2 equipment, obviously with typically a lot lower speed and flexibility. Next slide. So BRTE would, of course, be responsible for the flexible dual disjoint path or triple path. Even, in DetNet, they're thinking for even more redundancy. So the pref modeling, how we would want to do that with BEER, and that's also then the details, of course, are in the encapsulation draft. We would want to have an enhanced BEER header, include the sequence number. That's the new thing. BFR ID entropy act as a flow ID, so we can discuss that in the encapsulation draft. The BFR creates the packet with the sequence number with the flow ID. Any BFR, whether it's BFER or intermediate one, configured with the elimination function on ingress before the replication would eliminate duplicates, And that's the current thinking. Of course, that can still evolve in the details. There are a couple of things we're still reviewing. The linkage between BIER-TE and the pref function really is, the encapsulation already provides 50% of what we need. We already have in the encapsulation header also other fields that we're reusing that were only brought in for the application, not for BIER itself, like the BFIR ID is used for the overlay, not for the forwarding in BIER. So that, I think, makes it very logical to add the sequence number as an option there. And as I said, the elimination function does not happen after BIER is done, but it happens actually on ingress of any BFR. Next slide. So this is the example to showing what the benefit is of doing the elimination function on ingress, because it's really cool and better than what we could have done with, with the older multicast application. We just have two trees and there is no elimination function stitched in. So you're sending the same copy both ways around the ring, right? This way and this way. Each of these nodes on ingress does elimination function, but then copy further out in the direction and to the receiver for thank you. Not sure if that's, because I'm not allowed to go out of the thing. Oh, I'm so sorry. Right, so what basically happens, instead of sending, both copies through the whole ring, what happens is this copy only goes up to here, and then it sees, I've already got the packet, and the packet from the other side only goes here, sees it. So I'm saving 50% of bandwidth by doing the elimination function on ingress and doing replication afterwards, right? So that's a very cool example of how to improve this by being able to not do it just as an overlay on the edge. Next slide. Oh, this clicker doesn't work. Okay. So then basically comes the OAM function, and the OAM function is the ability to look at the received bit string and figure out which copy you actually got by the bits that are still in the packet. And so then you can basically also see you get, one or two packets, and especially in, the DetNet topologies which are not the ring, you will always get both copies, and you can create a lot better statistics in terms of, what the differential delay, and you can also understand where certain things failed along the path. So we don't have examples of that in this presentation. So, that's the key part that Pascal did add. Next slide. So yeah, changes from the 02 version. This has been around for a while, right? Fixed bugs, co-author, more explanation, more details about the elimination function, and then the ring example.
So you particularly bounded to BIER-T. If you look back how we did dual join live for PIM or MPLS networks, we would do it per hop. So if you do it with flex, algo, and colored link, you are done. You just joined. I mean, you don't need to implement traffic engineering to do this.
So that's I think very much a question also to the use cases in in DetNet, where you may want to have across different path segments along the path different amount of resilience. So I was saying exactly, I don't want to have this part of the solution be applicable to only BIER-TE, and that's exactly the header discussion. I would like to have this header which is applicable to BIER and BIER-TE with a sequence number, so that when we're using BIER, we can exactly use, I'm calling it dual topology. I'm not sure with all these new words like bar and IPA and stout, and so exactly, right? Yep, I think that was the last slide.
Questions? Intent of the draft? What's your intent with the draft?
Yeah, I think this particular draft, I think once we feel comfortable with this, I think it should be, I guess, informational, probably, because the normative part would just be the encapsulation, and then we'll have to figure out where to define the elimination function. The prior slide said that we need to figure out which pieces we can say are generic across different encapsulations, so that we don't have to define it in BIER, and which pieces of that are BIER or BIER-T specific.
Thanks. And BIER-TE encap. You do the encap?
Yeah.
All right.
Okay, so after Taurus talk about this is BIER-TE encapsulation. Yeah. Okay. This is some highlights we summarize for this whole draft. currently all the details are basically our best guess. And this draft proposed an enhanced version of encapsulation for to support both beer and BET. Of course, it's based on RFC 8296. Currently, we propose it to make it a version 2. But of course, it is possible. It's also possible to make it an alternative version. And in addition to that, this encapsulation support for allow beer to be used in .NET. Anyway, this is just one choice, and of course we're open for other options if you have any good suggestions. Next, please. Okay, the first feature of this encapsulation simultaneous support for beer and BET. Actually, oh, yeah, I should look at here. Okay, sorry, just to find out. Every domain should only use a single type of either beer or BET. Of course, it could be achieved by additional signaling, but there are some cases that may have the case beer and BET together exist in the network. So some configurations may be increased. This we propose.
Sorry, I think there was a typo. I think this meant subdomain.
Subdomain. Yeah, of course. Sorry. This we propose to include one bit in the the packet header to explicitly indicate what the type of beer or BET. So, question?
Cisco. I don't think we want to include a bit in the header because it's the outer BIFT ID, right? That will indicate whether this is what table you want to look at. It can be a beer table or a BET table.
Yeah, we discussed
I don't think a bit is necessary.
Yeah, we consider it, but the problem is that for current MPLS encapsulation, it can solve it perfectly. But there's currently for non-MPLS bit encapsulation may have some difficulties or something because currently the label hasn't be the format of the label or something like that.
I think it's mostly a question of how much self-diagnostic do we want to have, right? So that's the discussion point. Because the sender, when he sends it, right, you basically have consistency against what the sender intended the bit string to be.
Yes, but I don't think there's a big difference between MPLS and non-MPLS. Let's say in a non-MPLS case, you have to say what BIFT ID you associate with the subdomain, the bit string length, and what encapsulation you're using, right? Or what BET or normal beer. I don't think there's a difference.
Yeah.
Okay. Actually, yeah. Okay. This is just some explicit option to do it. But also, as I said, it could be some implicit option. Yeah. Okay. Another feature for this encapsulation is that the support for .NET. So this proposal adds a control word field to the header to allow the encapsulation used as a .NET data plane. And this field is 32-bit. And for .NET, currently only 28-bit is used as a sequence number and plus 40. So this sequence number is allowed to correct ordering and some discovering packet loss when using resilience dual path transition in .NET. Our authors, we think this overhead is acceptable, but even if some people think that maybe in some cases other than .NET, this field is not is useless. Maybe an option could be use one bit to indicate if the field exists or not. Other than that, also .NET needs a flow ID, so we do it by reusing the entropy field. Yes, please. So basically, this the packet format looks like. So three changes, extensions. The T field indicates the beer or BET. When the set is BET. Entropy is unmodified, but can be reused. For control, yes, I explained yeah, in the previous slide. So next, please. So I think this is partly discussed in Toilet's slides, but there's that's one option. Also, another option could be, maybe use BRT itself to assign new adjacency type for to achieve the resilient operation. Yes, please. Yeah, there were some discussion in last IETF meeting about the BSL length, which may limits BRT usage. That's because the size of the topology, the BSL indicates the size of topology towards BFER, and the path can be explicitly be engineered to reach it. That means that it consumes more bit position than the beer. So, but in our opinion, there's still some ways could be used to reduce the number of bits could be to assign it to the intermediate hubs in BRT. There's two examples. One is IPTV topology. We can see here. For IPTV topology, if we use BRT, it looks like a tree topology, and all the traffic from BFIR to BFR, from BFR to BFR1 to BFRN, all the traffic are maybe all the same, so they can share the 1 bits, but the traffic engineer happens from BFR to BFER. So this there's maybe multiple passes in between. So in this case, we can assign 3. In this case, we can assign 3 different bits to each pass. And since this topology could be is similar from the same the topology from BFRN to BFERN, so these 3 different bits can be reused in such kind of similar topologies. So in this way, some bits could be saved. Yeah. Sorry. Okay. Yeah. Let's talk about next step. Yeah. So we talked about using it as a version 2 encapsulation, and if we agree to do that, should we use this version to, maybe solve some BFTID assignment issue? Yeah, that's just some open question. We didn't propose anything in this draft. So, yeah.
Cisco, maybe can you summarize what the BIFT ID problem is here?
I mean,
assignment. Because you're saying there's no automatic way to distribute them.
No, I'm talking about the yeah.
But
not just.
Let's say if there's a need to distribute the BIFT ID for non-NPLS, we can do that, right? We can add it to the IGP or anything. So I don't think there's a version 2 encapsulation necessary for that.
Yeah, that's.
Thomas, I think the main point for thinking about that distinction was really from the sender indicating I meant a BRTE bit string as opposed to a beer bit string. That's, I think, the key diagnostic. I think for the other points, I would agree that basically we can distribute however we do the BIFT stuff, right, through IGPs or other schemes. But how do we, get the application to? I mean, I like diagnostics, but that would be my question mark, right? Is it worth a bit? Right. The key thing for us really is to have both for beer and BRTE the interpretation and the sequence number stuff, so that we do the resilient stuff. Mm-hmm.
Yeah, but for diagnostic you have the whole OAM support. So why don't you just put a special OAM packet? I can go and test whether my path is consistent. Because otherwise everybody with their special little operational hobby will try to stick a bit to see it on NCAPs. It doesn't scale, right? That's why we put OAM into the technology from bottom up.
And the sequence numbers, it may actually apply to normal beer too, or not?
No.
Yeah,
If
of
you wanna-
course, of course. Yeah, yeah. No. I mean, that's why the header is not meant to be a BRTE header, and maybe we need to
Yeah.
change the title again. That was meant for beer and BRTE with the sequence number included,
Yeah.
and distinguish somehow that the sequence number is included, whether version or a bit or so. So the whole bit. Let's separate the discussion of the bit to indicate whether it's beer or BRTE as a separate
Correct,
issue.
from the control word. Yeah, from the version 2. Yes,
Exactly.
Let's separate the discussion.
So
Two
you
different
like
discussions.
OEM, I like in-band. So I think that's the discussion to have, right? Active probing versus always wasting a bit. I don't like the slippery slope. Like if you assign a bit to this, what happens in 100 years with 50 bits added? So I mean,
But those are the real problem you face over time when you develop the technology.
Right, but you still need to make.
We'll dig
some
you up and
judgment
ask.
call.
Yeah. What happens in 100 years? Asking what we do with this bit. I said, we'll dig you up and ask. Thanks.
All right. Thank you.
Hello. Good morning. Good afternoon, everyone. I'm Jin Rong from Huawei. Because of my English, I need this backup. Can you help me to ask me question after I finish my presentation?
Yeah, that came to the list as well, asking if we can aggregate questions at the end. So let's just do that. Let's try to be consistent and get through this thing.
So hold back, you motley crew.
Yeah, hold back.
Thank you all. So, what's the problem of beer transition? This page shows current beer offers a way of packet replication along unicast paths, and one of its benefits is fast convergence. However, when we talk to some service provider, they have two different concerns: fast or even lossless switchover, like live, and deployment on existing network with few updates of hardware as possible. So, next page. So the first problem, current beer MVP drafts deliver a solution of MVP using IGP beer. It is on a many-to-many topology, and the multicast is along with unicast. However, it can't support a multicast specific path, something common in legacy MVP deployment. So that's the first problem. Transition from legacy MVP without losing the ease of many live disjoint paths is lacking. So the next problem. The beer architecture FC also provide a solution to support incapable mid loads. However, it can't support deployment on a network with incapable edge loads. It is also common in some SP networks that most of the loads are edge loads. Two examples, a hub-spoken topology in metro network, and another example is a ring topology in backhaul network. So transition from legacy MVP in networks with incapable edge loads is lacking. So this is the second problem. The two problems seem to be well known. You can see many people put their concern on these two problems. Next page. So what's the alternatives to solve the two problems? For the first problem of two disjoint trees, we may want to compute the two disjoint tree using some algorithm. And then how should we do? Just computing, and computing, or just build it? This draft is determined to just build it. And for the second problem of incapable edge loads. The beer architecture FC has clarified ingress replication do not fit to incapable edge loads. So what's the alternatives? I didn't see any, but this draft introduced some. So the applicability statement, this document introduced three points for beer transition. The first is a seamless transition mechanism from legacy NGM VPN by applying a beer encapsulation in data plane while preserving existing features such as live disjoint paths by using existing protocols. And the second is a seamless live protection by reusing the pair flow entropy field as a pair flow sequence number. And the third is seamless deployment on networks with incapable edge loads. This is a deep exploring of tree-based beer forwarding. This is mentioned but not explored in the beer architecture RC. And from this exploring, we can support incapable edge loads, which is not supported by the beer architecture RC. And also we can support incapable mid loads without using the ingress replication in the beer architecture RC. So the whole picture, the magnificent part of the whole picture is the step 0 in the right top. That is to use MLDP or RSVT or PIM-SIM, PIM-SSM to build a tree with beer information. That is a beer underlay procedure. And after that, all things done, service can run. And it will solve the problem, the first and the second problem mentioned before. So let's take a look at the data plan. Next page, please. So that's the data plan. First of all, we can see that label, the beer label is also a P2MP label as well. And the label will change hop by hop when packet replication. And the beta string inside every packet unchanged hop by hop. So this will, this will bring some extra simplification in data plan. And need to a better ability to handle incapable loads. And next page. Then the underlay protocol for P2MP beer include MLDP, RSVT, and PIM. To highlight that they all need the configuration on edge only. And any of the protocols can go and run an errand to build the tree with beer information. So summary, the two problems and the three seamless points and the philosophy is very simple. That is, you need any of the disjoint tree, then just build it. And the target scenario is for beer transition from NGM VPN. And there may be a focus question since IETF 100. That is simplification or complication to bring the tree into beer. And for this question, I have the following answer. In my opinion, from the view of beer transition, it is a simplification to introduce trade into beer. Because if something important lost, like leave, or some more complicated things are required, like hardware upgrade, then it is a backward and make the deployment very complicated. So that's it. And in the next page, some common comments are listed. Yes.
Yeah, we're tight
Mr.
on
Rung,
time.
I think,
We're really tight on time.
If the list comments already hit you, please point it out. Thank you.
Okay, very good. Yeah, I think we need to end. I just wanted to speak my piece because I have to go right now as well. But I think it would be helpful for and we need more time in beer, by the way, for next.
Yeah, I know.
But it would be good for this working group to decide whether transition mechanisms are important or if they are not important. Do we want to be hardline with saying that a network, if it's going to support beer, it has to support beer, or do we want to be more flexible to allow operators to be able to run both at the same time? And that's kind of the idea for this, is we're working with operators who are saying, we don't see the benefit of beer. And we're saying, you know, we believe in beer. We have an implementation coming up next year. This is a way for you to feel comfortable running both and transition to it. So that's kind of the idea. Does that make sense?
I think
Whether you
just
agree with it
speaking, transition is definitely part of our charter, and we have to evaluate cost of transition, right?
Yes, I agree.
And sometimes transition tools never go away, which is also a problem. So we have to think of it as a carrot and not as mud. You
Yeah,
get stuck in.
I agree.
Right?
So
Okay.
maybe we even need to get a separate transition document, maybe to talk about different
Could-
methods. But anyway, I'm sure other people have a lot of questions, but I gotta go.
Yeah, I know. I wanted to get to this though too. Are there specific questions about this draft? We have one more to talk about. We're probably gonna be kicked out of this room. We got pretty darn close to the end. I'm impressed with.
Blue sheets, please.
Yeah, blue sheets. So I have to apologize to, resilience draft. Anyone wearing a shirt? Get up here.
Yeah, let's have a photo with the shirt.
What's that? You didn't bring your shirt?
No. Wait a second.